Hi guys, welcome back to my channel. Today I want to talk about electric field. So if you feel electric field is a super challenging topic for you, you are not alone. Because we all have the feeling that we've been learning this for 5 times, we memorized 10 equations, we made 20 Anki cards, but for some reason, we could never get it right, all right? We never ever really conceptually understand what is going on. So I've been wanting to do this video for a really long time, but I was just taking my time to figure out some explanations that will make sense to you today, all right? So let's dive into this. So I will go through the concepts listed here, and then we're gonna go over a few MCAT questions that's related to all these concepts, all right? So the first big question I have for you is, what is an electric field, right? What is it? Is that a physical field that we get to see every day, right? So the answer is, it is hard in a way that we never get to see it, okay? But it is there. It is physical. We just don't get to see it due to human vision biology, right? I guess things are there, but we don't get to see it due to our biology. So this thing that we don't get to see but truly exists physically is due to a charge, okay? So it's really easy in a way that if you have a electrically charged thing, right? It's a particle here. It's a positively charged particle here. And then the area that surrounds it, that's as simple as it sounds. That's the electric field, okay? That's it. And then in my field, I can have another charge, right? Another positive or another negative charge, right? And then the electrostatic force is really the attractive force between this positive and the negative thing, or the repulsive force between this positive thing and the other positive thing, right? That's electrostatic force, right? And then the electric field line is really a line that goes from the positive charge to the negative charge. So you have another negative thing here, I can draw another electric field line, okay? That's the MCAT level that you need to, that's it, okay? That's very superficial level that you need to know about what is an electric field, what are electric field line, right? What are electrostatic force. But we also need to know that Coulomb's law gives us a way to mathematically quantify the magnitude of the electrostatic force, no matter it's an attractive force or repulsive force, right? So the equation is F equals this big K, Q1, Q2 over R squared, right? And then this K is just some constant, right? That will be provided on MCAT. And then Q1, Q2 are just the charges of the particles, right? Like, I know you're positively charged, but like how much? Is it 1 Coulomb or 2 Coulomb, right? So these have the unit of Coulomb. So this whole thing is Coulomb's law, right? And then this R is really the distance between the two charged particles, right? So let's say this particle A, right? And then this is a particle B. So between A and B, it's 2 meters. So I just plug in 2 squared, okay? So between A and a particle C, right? They have a attractive force in this case. So we just gonna, if it is 1 meter, and then we just gonna plug in 1 to 1 squared, okay? So that's it. I mean, it doesn't matter if it's attractive force or repulsive force. This equation calculates the magnitude of the electrostatic force, okay? And then I believe that you also remember another equation that is that writes like F equals big G M1 M2 R squared, all right? What is that? That is the universal gravitational force equation, right? So the big G is really just a gravitational constant. It's a constant, right? And then M1, M2 are the mass of 2 objects, right? And then R squared is just the distance between the 2 objects, right? So as you can see here that these 2 equations are really similar, right? In the way that the big K and big G, they're both constants. And then the Q1, Q2 are really the intrinsic, extensive property of the charged particles, right? Whereas the M1, M2, they're the mass. It just weighs how much it weighs, right? The mass. It's 200 kilogram, 100 kilogram, I don't care. But it's really the intrinsic property of the objects, right? And then they're both over, the denominator are both R squared, the distance squared, right? So, I mean, we have really, equivalent formula for our universe, okay? So that's the electrostatic force equation, Coulomb's law, and our universal gravitational force equation, right? Okay, so people come up with a G, right? So we know that F equals ma, right? And then we have a special acceleration G, right? That is due to gravity. And then we all know that's 9.8 meter per second squared, or on MCAT, it's rounded to 10, right? Okay, so what is this G about? So really, this G is really this big G times m1 times r squared, okay? So because we're on Earth, right? So this is the scenario on Earth that we know the mass of the Earth, I'll say it's m1, okay? And then we know the radius of the Earth, which is something, right? So imagine if you are m2, the Earth is m1. You are standing on the Earth. We can really ignore your height, right? Your from your center of mass to the surface of the Earth. We can really ignore that because comparing to the radius of the Earth, that can be ignored, so that we know the radius of the Earth, which is just the r squared that we plugged in here, right? And then we know the big G constant, so that the yellow highlighted thing gives us this acceleration on Earth due to gravity, okay? So that this m, this m here, or F equals mg, right? Same thing. Okay, so really this m here is really just a what? m2, right? And then all the yellow things in a case of Earth, it's really the mass of the Earth times big G over r2, okay? The radius of the Earth squared. So that's the small g that we get, okay? And it what is it called? It has a different name. It's called a gravitational field, okay? So this G is called gravitational field. So it describes like how strong this gravitational field, how strong that field it is, right? Okay, so we also need something. Scientists came up with something. Just like they can describe gravitational field, how strong that is, we want something to describe how strong the electric field is, right? These are both fields you don't get to see, but they're there, right? So the electric field strength is denoted with a big E, okay? And then the SI unit is volts per meter. Okay, that's the SI unit for the strength of the electric field. Okay, so how do we, in this case, it's not really this big K times Q1 times R2. Technically you can, because people must have come up with the Q of the Earth, right? The net Q of the Earth. But usually on MCAT, the scenario is that the MCAT will tell you constant electric field, okay? And then they will say, okay, there's this constant electric field E, okay? And then E is let's say 10 volts per meter, okay? So that they will provide you this. And then this E really is just like the G that describes the electric field strength. Okay, they're equivalent, right? And then you really know this G since what, 6th grade, right? So that, but this E is a really a new thing, right? If you have taken AP Physics, that's when that was introduced. Or if you're studying MCAT, if you haven't taken any physics class, this is the first time you see this probably. So all I'm saying that it's all equivalent. It's a homologous, right? Okay, perfect. So this is this E, okay? So this E describes how strong the electric field it is, okay? So we call it electric field strength, okay? The big E. Okay, so now we want to know the force, the electrostatic force, okay, due to the electric field. So just like F equals mg, this is really F equals what? Q times E, okay? So as you can see, this E is here, right? And then this is not mass here because we're talking in the context of electric field. So this is really the charge, how many coulombs of the charged particle, right? So as you can see, all the pink stuff that I highlighted, they're the intrinsic properties of either a charged particle or a an object, right? And then all the yellow highlighted things, they're the strength, right? So it's just like, okay, the force is experienced on Earth. So this is really like the on Earth scenario, right? And then this is a general scenario. And then this is also the general scenario for, okay, the way to calculate the electrostatic force. But this is really a not on Earth, but I'll say a constant case. When I give you a constant electric field, right, we can come up with the devices like a battery or capacitor, something like that, right? They can come up with the constant electric field, right? They come up with a constant electric field, and then you can just calculate the electrostatic force given this constant electric field strength. Does that make sense? Okay, perfect. So just to give you this visual presentation, a constant electric field is just something like that, right? Everything in there, they experience the same amount, the constant strength of this electric field, right? Due to the setup of the device, where this point charge scenario is when we use those general equations to calculate, right? It's not a scenario on Earth anymore, right? Because if you were in Mars, right, this M1 of Mars will be different than a mass of Earth. So you can't really use this G as your acceleration, right? You have to really plug in this general equation, right? And then that's the case for point charge, right? Point charge, like you don't, if I don't tell you, I give you a constant electric field, then you really have to use this general equation to come up with the electrostatic force, okay? I hope that's clear enough, okay? So I need to circle back and then give you more equations here regarding this E, okay? Because from this, we know that we can rearrange it. E is F over Q, right? Okay, but I need to give you another equation that's very high yield on MCAT. I have to circle back, okay? So I have to talk about potential energy first, okay? Before we circle back, okay? So potential energy, we also have a general equation, right? We have a general equation. Let's talk about the gravitational potential energy first, okay? So now I'm talking about energy, okay? So potential energy, PE, okay? So we know that the general equation is negative G M1 M2 over R, right? But on Earth, you know that this PE is what? MGH, the very famous MGH that you know, right? Okay, so now let's talk about the electric field, okay? So just like the general equation for the gravitational potential energy, we have a general equation, or I can say point charge or general equation to calculate the electrical potential energy, right? Not gravitational potential energy anymore, but the electrical potential energy. So that is also big K, Q1, Q2 over R, okay? And then as you can see that the R, the distance is inversely related to the potential energy, right? As you have a smaller distance, that will give you bigger potential, right? And then if you have a large distance, that will give you a smaller potential energy, okay? Just inverse relationship, okay? All right, so this is the general equation for the point charge, okay? For the point charge, the electrical potential energy. And then you may have guessed, if I give you a constant electric field, and then what is PE? Like we can mimic this, right? This is, okay, M is the mass of the object. So for my charged particle, it will be Q, right? Q times what? Okay, so in this case, this G is the strength of the gravitational field. But so now I need something to describe the strength of the electric field. So that will be what? Big E, right? And then this is a height, right? Because you're always standing on Earth, it looks like vertical, something like that. But in this case, we say it's just distance, right? I mean, DH there, same thing, but just human convention. All right. Okay, so this is the potential energy of a constant electric field, right? Okay, perfect. And then also, do you guys remember like the definition of potential energy? What is that, right? Could you conceptually understand it, right? So really, the definition of potential energy is really the potential an object has to do the work as the result of being located at a particular position, right? Let's say that this is my Earth, right? And then there's a thing. Let me see. Should like a bird? Maybe I should draw. Oh, this is horrible. Okay, I'll just draw a balloon. Okay, so a balloon is over there, right? It has a potential energy, right? Because mgh, right? There's a height. Okay, so to stay there, I mean, this is like potentially the work then object has to do. So if you look at here, this mg is like just like F equals ma, right? G is a special A. So this is really force. This is really the gravitational force, times whatever height you are, right? So basically, this is another way to interpret this equation. And then also I can say that this potential energy is, so this G is like how strong my gravitational field it is. It is what it is. It is on Earth, it's just 9.8, right? It's that much strong. Then the potential energy really, right, depends on how strong the gravitational field it is, and then also like the mass of the thing, and then where you are, the location, right? So the same thing in the electric field, this E, it is what it is. It's a constant. It's a 10 volts per meter or whatever, 200 volts per meter. It is what it is. And then really the potential energy that the thing need to do, let's say this is my electric field, right? And then this is a positively charged particle, right? The thing that because otherwise it can be either attracted or repulsed, right? It depends on what charge you have in there. But I mean, it is what it is. You have this constant electric field strength, and then it really depends. The potential energy really depends. This is really what? This is really F. This is really F. D, and then this F is the electrostatic force, right? Where this F is the gravitational force, right? Remember, F equals QE here. F equals QE, right? It likes work, right? Work is like force over a distance, right? So, I mean, on MCAT, I always like to think, okay, work is just energy. I mean, this is not precise. I mean, to be precise, work is the change of energy, right? Delta energy. But a lot of the times, you can just, for the purpose of MCAT, okay, work is just energy. Because see, this is energy. And then it's basically, F times D, F times H. It's just what? F over distance. That's work, right? So they have the unit joule. Okay, perfect. Okay, so hopefully that clears up some of your confusions. And then, okay, so we can keep going. Okay, so I also want to introduce voltage, right? And then voltage, according to the definition, voltage is really just the potential energy per charge, right? Potential energy per charge. So now we have this equation for the potential energy given a constant electric field, which is what? Q times E times D, right? I'm just copying, pasting this. And then overcharge, charge is what? Q. So you can really just cancel that out, right? So that gives you what? Gives you V equals ED, okay? So because V equals ED, my E equals what? V over D, right? So that is the second equation I want to give you. I want to circle back, okay? E equals V over D, okay? And then when you use this one, F equals Q, that will give you the unit Newton per Coulomb, right? And then when you use this one, it will be volts per meter, right? Because this is voltage, okay? Volts per meter, okay? So the importance of recognizing the units is sometimes like the physics passages can be hard, right? You have no idea what that setup is about. You were sweating, you want to pull your hairs out, It's very stressful during MCAT exam. But if you if you know the units, you can really just go to your passage and find, okay, how many volts, how many meters, whatever, the passage is talking about, but you recognize the units and then you can do the calculation, okay? So that's the magic, that's the magic of units, okay? Knowing the units on MCAT. Okay, so now we have like 5 variables here, okay? So let's see. So you have a E is a variable, right? And then you have a F is a variable. And then you have a Q is a third variable. And then the fourth variable is a voltage, V, right? And then the fifth one is D, distance. So MCAT, these 5 variables, they can play with it. They give you like they give you three knowns, right? They give you this, and that, and then you can figure out the other 2 no matter what they ask you in a question, right? So they can give you 3 knowns in your passage, right? If you don't understand the content of the passage, that's okay. Look for the units, right? You recognize Newton, you recognize Coulomb, right? Those units, and then you can calculate the other unknowns, right? We're gonna do an example, okay? So Let's do an example. So let's say I'll just make up something, okay? But I promise you this is MCAT style, okay? So let's say, let me think really quick here. Okay, so let's say I have a charged particle, okay? And then my charged particle, so now my known, I'll tell you the knowns are this charged particle is, let's say 20 coulombs, okay? I made it up, 20 coulombs. And then I can say something fancy like, okay, I'm gonna drop this 20 coulomb charge particle into let's come up with something fancy. I'm gonna drop it. I'm not gonna say I'm gonna drop it into a constant electric field, right? That's too straightforward. I'm gonna drop this particle into a, let's say, parallel plate capacitor. Did I spell it right? Capacitor. Okay, so that's my wording. It's fancy. It just means constant electric field. Okay, all right. Okay, I drop this thing into this parallel plate capacitor. Okay, and then I say, okay, after I drop this 20 coulomb particle into this electric field, this particle feels a force. Okay, a force of a 200 Newton. That's what it feels. So you know that's what force, electrostatic force, right? Okay, and then I say, okay, and then the distance between those plates are what are, I say, 1 meter, okay? That's also a fancy way to say that between the two different particles, the distance between two particles are 1 meter. But I'm just being fancy here like MCAT. So I say, okay, the distance between the plates is 1 meter, okay? So I ask you, so the unknown that I'm asking you is, what is the voltage across the capacitor? Okay, I want you to solve voltage. Okay, so you see here you have three knowns, right? 20 coulomb, 200 Newton, 1 meter. Even if you don't recognize what the passage is talking about, you recognize coulomb, Newton, meter, and then you can plug in now, right? You can plug in then, okay, it's asking for voltage, right? So for voltage, but do I know my E? No, I don't know my E, right? Because I have to calculate my E. E equals F over Q. The F is 200 Newton. And then my Q is what? 20 coulomb. So this gives me 10 Newton per coulomb, or 10, the SI unit is a meter, volts per meter, but it's okay, right? We accept both units. Okay, so that gives me the strength of the electric field. And then now I can use the second equation to calculate my voltage, right? Because my E is a 10 Newton per coulomb here, and then voltage over distance is what? 1 meter. And then your V is 10 volts. There you go, right? Easy, okay? So that's what MCAT would do, right? 5 variables. They play with it. They come up with fancy passages, but just calm down, okay? You're good, okay? All right. So that's it, okay? So I actually want to do a few more problems before we jump into power, okay? So I want to do a conceptual problem, okay? It doesn't require calculation, but okay, right, listen now. So I have a particle A, okay? It's right here at point A. I'll say it's a positively charged thing, okay? And then a positive charge. Okay, so it's this positively charged thing is at point A. So I have another fixed positive charge somewhere. Okay, so I'll say here another positively charged particle is here. Okay, so now I'm gonna say that. Okay, so now I am gonna release this particle, right? And then because this thing feels repulsion with this one, so if I release it, it would come to point B, right? From A to B, okay? From A to B, it would be more far away from this positive thing, right? Because they repel. Okay, so I'm gonna ask you, how does the voltage change? Okay, as I move from A to B, how does voltage change? Okay, so how are we gonna solve it? Okay, so as you know, voltage is what? Voltage is a potential energy, right? Potential energy over charge, okay? Coulomb. Okay. But I mean, I don't know, right? The question never tell you what are the coulomb, how many coulombs are those charges? You don't know. And then you also don't know how to calculate the potential energy, right? No numbers provided, but that's okay. Conceptually, we can see how does the PE change, right? How does the PE change? If the PE increases, then we know the voltage increases. If the PE decreases, then the voltage decreases, right? Okay, so, but how does the PE change? How does the PE change? Okay, you're like, okay, PE equals QED. Okay, how am I going to know how does the PE change? But remember, this is really a point charge scenario that we need to use this equation. Okay, this is really a point charge scenario. Okay, that we know the R increased or decreased, right? This R really what? Increased. This R really increased. Then what about P? Because R is the denominator, right? So R increased, the whole PE, the whole thing would decrease. Okay, so my whole PE is gonna decrease, okay? So this V, voltage, would decrease. So how does my voltage change? My voltage will decrease from point A to point B. Okay, that's the answer I'll pick. Okay, perfect. All right, let's do another one. Let's do another MCAT style, okay? Should I come up with something easy? Let's see. Okay, so let's do this. Okay, we'll come up with something easy. I'll say I have a charge, okay? It's 1 coulomb. And then it's pushed against a constant electric field that is let's say 10 volts per meter, okay? So this is my constant electric field, okay? So this thing gets pushed away. Pushed away. So it's away, okay? So it's away from it. How far away? Let's say 10 meter away. 10 meter away. Okay, so the question is, what is the potential energy gained by the particle after being pushed away against this 10 volts per meter constant electric field for a distance of 10 meter, okay? Okay, this is really chill. This is mellow, right? This is a constant scenario, okay? So this is this constant scenario. So I'm going to say PE equals QED. And then Q is 1 coulomb, E is 10 V per meter, D is 10 meter. That gives me what? 100 joule. Okay? That's how much the potential energy that this particle gained. Okay? Okay, all good. All right, so now we can move on to power. Okay? So relating to this topic, power is really equals to V times I, right? And then it's a watts. That's the unit for power, okay? And then this is a velocity. Oh, sorry, voltage. What am I talking about? This is voltage. This is a current, right? Amp. A is the unit for this, okay? So this is the scenario. If you are dealing with the physics class, physics passage that's dealing with electric field, then this is the equation you use for calculating power, right? But if it's the different context, let's say it's the passage is about simple machine, right? Something about work, then we know that we learned other equations like from previous chapter, the power equals what? Like a work per time, right? Per T, right? In this case, the unit is a joule per second. Or like P equals work can be F times a distance over T, right? That's the same thing. And that will give me Newton meter per second, right? And then we say, okay, this D over T is basically velocity. So we can say power equals F times V as well, right? Then that will give you the same unit. Newton meter per second. Okay, so these are the cases where you use the power equation in the context of a work, simple machine, things like that, right? But in the context of electric field, you would use this equation. Okay, so yeah, let's do a problem, shall we? So let's say I say I have a calculator, and calculator uses 2 electrodes, right, separated by a distance of let's say 2 meters. So here I'm being fancy again, right? 2 electrodes on MCAT means what? This constant electric field. Okay, all right. So they are 2 meters apart. Okay. And then I say this thing has a potential difference of 10 volts. Okay. This has 10 volts. All right, so if I have a current that is going through this, okay, so electrodes, this is current. So current go, right? So my current is, let's say, 1 amp. Okay, it's 1 amp. I ask you, how much power is required to run the calculator. Okay, so I told you, you use the equation P equals what? P equals V times I. All right, V is 10 volts. I is 1 amp. So your power is 10 volts, okay? So this 2 meter is just a distractor, like the typical MCAT trap, right? It's 2 meter because you're gonna think, okay, oh yeah, I know the E, right? E is 10 over 2, right? It's a volts per D, right? You say, okay, I get a 5 volts per meter. Okay, perfect. I have my E. And now you're stuck. Okay, I know my E. How do I calculate P? Because P is equals VI, right? That's okay. Just forget about this too. Don't bother calculate this. Just plug in 10 and 1 and you got this, okay? All right, so that wraps up my video about, I think I went through all the topics here. I hope that's helpful. If you have any questions, you can leave a comment down. I'll make sure that I get everything cleared for you. All right, I hope that's helpful.